I still vividly remember, like, sitting at my kitchen table in high school, just staring at this one calculus problem.
Oh, I've been there.
Right? I mean, for 3 hours straight, it looked like absolute gibberish. My brain was completely tied in knots.
Yep, the classic math wall.
Exactly. And then my tutor leans over, draws one single line on the paper, and points out a totally different way to look at it. And instantly, the entire problem just unzipped.
Wow.
Yeah, everything clicked.
It's an incredible feeling, honestly, that sudden, violent shift from total confusion to just total clarity, the pure aha moment.
And delivering that exact aha feeling to you is the mission of our deep dive today. We are exploring this fascinating new paper from OpenAI, revealing how an internal version of their upcoming Astra model just solved 10 major, decades-old open problems.
Right, in mathematics, theoretical computer science, and quantum complexity. It's huge.
It is wildly optimistic stuff. Today, we're going to unpack exactly how this AI pulled this off and why it signals this thrilling new era for human discovery.
Because the sheer scale of the achievement is historic. But, if we look at the mechanics, it wasn't just a machine spitting out an answer in isolation.
Right.
These mathematical proofs, they only cost about $2,000 in compute tokens to generate.
Which is mind-blowing on its own.
Totally. The AI formulated the proofs and then verified them in this programming language called Lean, producing these Lean certificates.
Yeah.
But human mathematicians actually prepared the final manuscripts.
So it was a true collaboration. I keep picturing a buddy cop movie.
A buddy cop movie.
Yeah. You have this brilliant, wildly fast detective.
The AI.
Right, the AI, cracking the case and finding the raw evidence, while the grounded, meticulous partner, the human, writes up the bulletproof legal brief so it actually holds up in court.
That is actually a surprisingly accurate way to look at it.
And speaking of flawless integration, getting AI and humans working together perfectly, that's exactly what today's sponsor, EmberSilk, provides.
Oh, definitely.
If you need help with AI training or automation, integration, or even just software development, EmberSilk is who you want. They help you uncover exactly where agents can make the most impact for your business or personal life. You can check them out at embersilk.com.
Highly recommend them.
So back to our detective. What did it actually solve?
Well, to prevent list fatigue, let's just highlight two massive wins. First, it completely nailed the exact exponential growth rate for high-dimensional sphere packing.
Okay, wait, stop right there. I need you to translate that into plain English. What is sphere packing?
Okay, so imagine trying to pack oranges into a wooden crate so that absolutely no space is wasted.
Right, trying to squish them in perfectly.
Exactly. In 3 dimensions, that's already a tough math problem. Now imagine trying to pack those oranges in 8 dimensions or 24 dimensions.
My brain just broke a little bit.
I know, right? The geometry gets so insanely tangled that the math community has been stuck on calculating the most efficient way to do it for decades.
And Astra just solved it.
It did. And secondly, it successfully disproved Kahn's rigidity conjecture.
Wow.
Yeah, by constructing infinitely many property T groups that share the exact same von Neumann algebra.
Okay, that sounds incredibly complex, but how does it actually do that? Is it just like brute forcing millions of combinations because it has massive computer chips?
No, it's doing something much deeper. The AI is finding entirely new structural patterns.
Really?
Yeah, patterns that have eluded us for years. And we know this because OpenAI released these reasoning walkthroughs. They document the AI's internal logic, including, its detours and roadblocks.
Oh, this is the part of the paper that really caught my eye. There was another problem it tackled called the closest vector problem, which is super important for post-quantum cryptography.
Right. Crucial for future security.
And while working on it, the AI actually hit a wall.
It did. The model documented that its traditional approach using something called signed histograms was just failing completely.
Because of cancellation errors, right?
Exactly.
Wait, you lost me again. What exactly is a cancellation error, and why did it stop the AI?
Think of it like trying to balance a really complex corporate checkbook.
Okay.
But you have these tiny rounding mistakes happening on every single line. Eventually, those tiny positive and negative mistakes compound, and they accidentally wipe out your entire balance.
Making your final number completely useless.
Exactly. And the AI saw this mathematical collapse happening in real time.
So how does a computer fix a math problem that is fundamentally breaking itself?
It deliberately pivoted. It entirely changed its underlying mathematical language to a characteristic 2 binary evaluation table.
Which means what exactly?
Basically, it switched to a binary system, just ones and zeros, where those specific negative number rounding errors literally cannot exist.
I have to push back here, though. I mean, does a pivot like that prove the AI has genuine mathematical intuition? Or is it simply exhausting thousands of different pathways at superhuman speed until it blindly stumbles into a workaround?
It's a really vital question to ask. But look, the walkthroughs suggest it's far more than blind speed. The AI recognized why a pathway was failing and deliberately chose a specific mathematical structure to bypass that exact vulnerability.
So it understood the trap and stepped around it.
Yes, that looks an awful lot like genuine reasoning.
That is amazing. So what does this mean for you listening right now? It means we're standing on the edge of a golden age of discovery.
Absolutely.
This isn't a story about machines replacing human brilliance. It's about giving our brightest minds absolute superpowers. I mean, OpenAI is even granting 100,000 scientists free access to their best models to accelerate this progress.
Giving human researchers a tool that can navigate structural roadblocks this efficiently, it will fundamentally accelerate how quickly we can solve real-world problems.
It leaves you with a pretty staggering thought. If an AI can crack 10 historic, seemingly impossible math puzzles for just $2,000 today, I mean, what fundamental secrets of the universe might you be able to uncover with the models of tomorrow?
It is an incredibly hopeful time for science.
It really is.
Yeah.
Well, if you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.